Hi friends, very good morning. Welcome to our class. Welcome to Anu Academy. Very good morning friends. So let us start today's class. Today's class we have selected a topic. Today's class we are going to discuss about the resultant of force systems. Okay, today's class we are going to discuss about resultant of force system. Okay, like that we are discussing our topics. Okay, so today's class we are going to discuss about resultants of force system. Okay, resultants of force systems. Okay, so we'll come to know what is a resultant, what is the important of resultant which is related to this force system. Okay, see, the effect of a system of forces on a body is usually expressed in terms of its resultant. Okay, since the value of this resultant determines the motion of the body. Okay, so if we can say like this, if the resultant is 0, if the resultant is 0, what happens? If the resultant is 0 means the body will be in equilibrium. The body will be in equilibrium. Okay, if equilibrium means will not change its original state of motion, right? The resultant is 0, the body will be in equilibrium. Means what happens if it is in equilibrium? Will not change its original state of motion. Next, if the resultant is not 0, next if the resultant is not 0, if the resultant is not 0, what is happening to the force system? The body will be very state of motion. Okay, we have to write the body will be varying, it will be varying state of motion, it will be varying state of motion. Okay, so right, so how we can understand this one, how we can understand this resultant? We have to demonstrate an experiment. Okay, so with the help of parallelogram law will come to know exactly what is a resultant. Okay, with the help of parallelogram we'll come to know what is the resultant, right? How we can take the forces and how we can show the resultant for a given system. Okay, so let us start now parallelogram law. Okay, parallelogram law. Okay, parallelogram law. So in this law we will come to know the resultant. Okay, at the end of this experiment we'll come to know what is the resultant, right? So the method of vector addition is based on this parallelogram law, which is one of the fundamental of mechanics. Okay, so it can only be demonstrated by a experiment, right? Now we will see the setup of this parallelogram. Okay, see, in this parallelogram what we are doing is we are taking three chords, right? We are taking three chords and we are tying these chords together. Okay, we are taking three chords and we are tying these chords together. So this is first one, right? And this is the second one. Okay, and this is the third one. Okay, first, second and third, right? So here we are, these are the free ends. You can understand how I am drawing. These are the free ends of this parallelogram. So if you are getting a question regarding this parallelogram, you can draw this diagram. Okay, so three chords we have shown here. These are the free ends of this is the Q, this is P, and this is W, right? So what we are showing is, see, listen here, three chords are tied together and they are fastened, the weights are fastened to the free ends. Weights are fastened to the free ends Q, P and W. Okay, so here what we are seeing that the sum of P and Q must be greater than W, right? So in this parallelogram, in this entire setup, what we are taking care such that the sum of P and Q should be greater than W. So here we are showing this arrangement, how it is connected. Okay, so if you are getting a question, you should draw in this way, right? Okay, so right now we have shown in this diagram taking the free ends of Q, P and W, right? Seeing that sum of P and sum of Q should be greater than W, right? Now what is happening here is the tensions in these cords will be equal to the weights P and Q. Okay, now what we have to show in this parallelogram in order to find the resultant, right? So we have to draw the vectors for P, we have to draw the vectors for P and Q, right, taking a scale. So which is the scale here? We are taking this point as the scale A. Okay, we are taking this point as the scale A and we are drawing the vectors of P and Q and W. Okay, now we'll draw the vectors. We'll plot the vectors. Okay, this is reference point A, right? So from this point we are drawing the vector for P, we are drawing the vector for Q and we are drawing the vector for W. Okay, so here we can plot the vector. This is the vector for P and this is the vector for Q, right? And here you can see this is the diagonal R of the parallelogram, right? So this is the, we can draw here, this is the diagonal of this parallelogram R, right? So here we can show the construction of this parallelogram. Okay, we can show the construction of this parallelogram. So for this is the vector W. Okay, this is the vector W, right? So we can show that the diagonal R of the parallelogram scales exactly to the value of W. So this is it is exactly equal to this value of W, right? So in this entire experiment, now we will come to know what is the resultant. Okay, so in this entire experiment we'll come to know what is the resultant. Since we can show the two equal opposite collinear forces are in equilibrium, we conclude that weight W will be perfectly supported to the force R, right? So both are in collinear, both are equal and opposite collinear forces are in equilibrium. So we conclude that weight W will be perfectly supported, the weight W will be perfectly supported by the force R. Okay, so we can show, we can say in other words, the net effect of the forces P and Q may be replaced by a single force R. Such a force is called resultant. Okay, so here we can write R is called a resultant. Okay, R is called a resultant, right? So parallelogram, we know that it is but we can say that these two forces can be replaced by a single force R. Okay, so this is the entire experiment of this parallelogram. So I think all of you understood how we came to know the importance of this resultant with the help of this small demonstration, right? So we have, I just have repeated once, we have selected three forces, right? We have selected three chords, and end of these free ends we have placed the weights, okay, P, Q and W, right? So what we are doing here, first we have plotted the vectors of P, vector of Q, right, and vector of W with a reference with a scale A, right? And we have plotted the diagonal of this parallelogram. So you can see this dotted line, we have constructed this parallelogram, right? We have plotted this parallelogram on this small demonstration, and we are showing that resultant R is equal to the vector W, right? And it support is also equal from R to the weight W, right? And what we are showing, what we are concluding with this parallelogram demonstration, we are saying that resultant R is replaced with this P and Q. Okay, so if you are getting a question, you have to draw this diagram and explain what is the importance of the resultant of force system, and show what is the resultant R, how we are getting this R. Okay, so hope that, I think all of you understood today's class. If you have any doubts, you can post in the comments box. I will give you a reply. Please subscribe our channel, please like our channel, please share our channel. Thank you very much. Thank you for watching. Okay, see, now we came to know about the resultant, right? And with this small demonstration, we came to know how to plot a parallelogram. Okay, now we will continue here the saying with one small statement. The parallelogram law shows how to combine two forces into a resultant force. Okay, the parallelogram law shows how to combine, shows how to combine two forces, how to combine two forces into a resultant force, into a resultant force. Okay, right. Next we can write here, next the parallelogram, how we have generated, we can write one more statement in addition to this. The resultant of two forces, the resultant of two forces, the resultant of two forces is the diagonal, is the diagonal is the diagonal of the parallelogram, diagonal of the parallelogram, whose initial sides are, whose initial sides are the vectors of these forces, are the vectors of these forces. Okay, like that you have to write in your exam. Okay, now we will see how we can construct this parallelogram. Okay, so now we'll have a small diagram. We'll see the construction of this parallelogram, right? See here, we can show that first we'll start with the resultant. Okay, this is the resultant with this IA. So we can draw like this. Right. Yeah, this is the completed parallelogram. This is the resultant R, okay, and this is A, this is B, this is C, D, okay. So this is R and this is P and this is Q, okay. So now the parallelogram is ready. So this is the parallelogram which we have seen in our demonstration, right? How we have generated this parallelogram, okay. So with this resultant R, right, we have completed this constructing the parallelogram, okay. So here we can see the resultant of two forces is the, so two forces, its resultant is the diagonal of the parallelogram whose initial sides are the vectors of these forces, and we are saying the parallelogram law shows how to combine two forces into a resultant force, okay. So if you are getting a question, you have to draw all these diagrams, so you will get a good marks, okay. So if we show alone this triangle and this triangle, right, so it will be easy for us for your getting good marks, right. So same way you can draw this one, taking this triangle, okay. So this is triangle A C B, okay, triangle A C and B, showing the forces. This is the R, okay, this is the P and this is Q, okay, this is Q. Same way, if we take this triangle here, we can draw same way here this triangle, right. So if you complete these diagrams, you will get good marks in your exam. So A, this is A, this is the resultant R, this is C, okay, and this is P, this is P, and A, this is D, and this is the Q, okay. So like that you have to show the construction of this parallelogram, okay. So these things you have to represent in your examination. Now we will come to know what is a free vector, okay. A free vector is defined as one which may be freely moved in space, as distinguished from a localized vector which is fixed or bound to a specific point of application, okay. So if you here in this triangle, which is the free vector, so force Q has been represented by the free vector B and C, okay. So force Q is represented by the free vector B and C, okay students. So if you are having any doubts, you can put in your comments box. In your examination, if you are getting a question regarding state and explain the parallelogram, these things you have to put in your paper, okay. Thank you very much. Thank you for watching. Please subscribe our channel, please like and please share our channel. Thank you very much.